is section 6A. We are graphing systems of linear inequalities. You guys have graphed systems of equations, right? That's what we did earlier in this chapter when we graphed two lines, two equations, and we tried to figure out where they intersected. At the end of last chapter, you graphed linear inequalities. Like we graphed them in slope-intercept form and shaded one side or the other. We're going to put those two concepts together. You know how to graph systems. You know how to graph a linear inequality. We're going to put them together and graph systems of linear inequalities. Okay? So the first thing we're going to do is go through our 4 steps here at the top and write in exactly what we're going to do. This will be a good resource for you to use. So please fill in this note sheet accurately because it'll be a good resource to reference later. What's the first thing we do? If we're wanting to graph anything, doesn't matter what it's system or just a regular equation, what do we do first, Melissa?
Put it in slope-intercept.
Exactly, and that's going to be our first step. We're going to say put each inequality into slope-intercept form. I'm going to use marker, but if you want to use your pencil or pen, you could do that too. Well, what is slope-intercept form?
Y equals mx plus b.
Y equals mx plus b. And of course, ours won't be an equation this time because it's an inequality, but that's the same form that we're going to use. So once we've got into slope-intercept form, what would be our next step?
Graph it.
Graph it. That's what we do next. We have put it in slope-intercept form so we can graph. So step 2, let's say graph each line. That means we're going to plot our y-intercept and move with our n, our slope. Now think back to when we did our inequalities, graphed our linear inequalities. We didn't just draw a line in, did we? Sometimes we had to use a different type of line. What was that?
Dash or solid.
A dash. And sometimes it was a solid line. So that's what our step 3 is going to be. Making that decision, do we use a dashed line or a solid line? I'm saying dashed line or solid line. We'll make that decision there in step 3. Think back to graphing linear inequalities. After we have our line graphed, what do we do next?
Shade the point.
Shade. Well, to get their shading, yes, we had to test a point. I'm going to say shade. But I'm also going to put here in step 4 to test a point. At what point do we typically like to test if we can?
0, 0.
0, 0. Now, there are certain times when you can't use 0, 0. What's the time or the one main instance when we can't use it?
Because 1 is 0.
Right. If our line goes through 0, 0, which it happens. It happens. Now, down below number 4, here on the left-hand side of your sheet, you'll see where it says solid line, dashed line. In those boxes, I want to put the inequality symbols that we're going to use when we have a solid line or a dashed line. Well, when would we use a solid line?
Greater than or equal to or less than or
Less than or equal to or greater than or equal to. So write those symbols in. Now what about a dashed line? When do we use that?
greater
Less than
than.
or equal to.
No, less than or greater.
Less than or greater.
Less than or greater than. And think about it. When we say these symbols up here in this first box, less than or equal to, we say equal to, right? Equal to, that solid line, anything on that line is equal to. So it would make sense to use a solid line. Now down here on the dashed line, we're saying less than or greater than. Doesn't say anything about equal to, does it? So anything on that line is not equal to. So we would have to use a dashed line to say it's more of a boundary line, not necessarily an equal to line.
How I usually remember it is that if the less than or equal to it's like it has a line under it, so it'd be a solid.
So it's
line.
kind of like half the equal sign? Is that
Yeah.
what you're thinking? Has a solid line underneath it? That's a good way to remember it. Saying there's a solid line under here, meaning we would use a solid line on our graph. Good thinking, Kimberly. I like that. What we're going to do here on this graph is I'm going to give you an example, and we're going to make a good graph here. So copy this down, please. I think you should have some room there at the bottom to do your work. 2x plus y is greater than or equal to 2. And x plus y is less than 2. This is called a system of inequalities. It's not a system of equations, obviously, because it doesn't have an equal sign. Let's go through our 4 steps that we just jotted down to help us graph and find where our solutions are. What's the first thing we're going to do?
Put it into slope-intercept form.
Put it into slope-intercept form. Looking at equation number 1, or inequality number 1, what would you do to put that in slope-intercept form?
Minus 2x.
Good. Subtract that 2x, so let's do that. So we have y is greater than or equal to negative 2x plus 2. Now guys, remember, if we did multiply or divide by a negative number, what do we have to do to our inequality
Flip
symbol?
sign.
We have to flip it. And it's very important that you do that, just like we did previously. Equation number 2, inequality number 2, what are we going to do to put that in slope-intercept form?
Subtract
Subtract x.
Excellent. Subtract x. So we have y is less than negative x plus 2. Now both are in slope-intercept form. We can graph them. For the first inequality, what is our y-intercept?
2.
2. So I'm going to put a dot at 2 on the y-axis. What's the slope of that first inequality?
Negative 2 over 1.
Negative 2 over 1 if you want. Think of it as a fraction. So down 2 and right 1. Down 2 and right 1. I'm going to go ahead and extend this just so I can get an accurate picture of what my graph's going to look like. I don't want to be sloppy with my work. I want it to be nice and neat. Now before you draw your line in, let's make a decision. Is this going to be a dash or a solid line? How do we know?
Good.
It's
got greater
than or
equal to in it.
It's got greater than or equal to. So if we use Kimberly's rule, it has that solid line, greater than or equal to. That symbol is a solid line, so we're going to use a solid line. Now we're not quite finished. We don't just graph the line, do we?
Nope.
What do we need to do?
Test a point.
Test a point. So we're going to try 0, 0 as we've talked about before. Let's put 0 in for x and y. I'm using the first inequality. 0 is greater than or equal to. Negative 2 times 0 is
0.
0. What's 0 plus 2?
2.
2. So we need to ask ourselves, is 0 greater than or equal to 2? No, that's false. So I'm going to put a dot here so that I can visualize what I've got going. I put 0, 0 in and I found that it was false. So what does that tell me about the side with 0, 0? This side is all false, isn't it? If I was to select any ordered pair from that side, it would not work in my inequality. So I want to shade the true side, so I'm going to shade the right side. This is where your markers come in. Shade one side, please. Let's go ahead and graph our second inequality. And the second inequality, what is our y-intercept?
2.
It's also 2, so we'll put a dot at 2, which we already have one there, and that's okay. What's our slope?
Negative 1 over 1.
Negative 1 over 1. So we're going to go down 1 and right 1. Down 1 and right 1. Our lines are pretty close together, so again, it's important that you're accurate with your work. I'm going to go up 1 and left 1 as well, just to continue my line in the other direction. Now, will this be a dash or a solid line? A dash, and how do we know?
It's not equal to.
It's not equal to, it's just less than. It's not equal to. So So take your straight edge and we would draw in a dashed line. Alright, so we do need to shade this line as well. So we're going to test an ordered pair. Still going to test 0, 0. So let's put 0 in for x and y. 0 is less than. Negative 1 times 0 is 0. And 0 plus 2 is 2. So I have the ordered pairs, or excuse me, I have the inequality. 0 is less than 2. Is that true?
Yes.
Yeah, that's true. 0 is smaller than 2. So thinking of my graph that I just drew in, I tested 0, 0, and it was true. So what does that mean about that side of the line? I need to shade that side. I'm going to shade the bottom or the left-hand side of this line. For this particular graph, you should have one, kind of like it looks like a triangle region up here on the top that's not shaded. Make sure that you're not shading in there, because that's not a solution for either of those inequalities. Now, as far as our answer, I don't want where the lines intersect. When we're graphing systems of equations, we would name that point where they intersect. I'm more interested in where do your shadings overlap. Can you look at the graph and easily tell where your shadings overlap?
Yeah.
Yes. So what I'm going to have you do, just for this example here, I'm going to draw, I'm going to say this area is your answer. This area is your answer, is what I said there at the bottom. And then I'm going to draw a line to that area. So that when I look back at my notes later, I know exactly what Mrs. Keller will be looking for me on a test or a quiz. Logan?
How would it be no solution if the lines were parallel and then when you tested them both with 0, 0 because then you didn't go through it and each side proved false, would be no solution?
If they were shaded on opposite
Yeah.
sides, that's correct. Very good. Very good. And that will likely happen.
Will there ever be a case where you'll have to do a whole graph, like color the whole graph?
I'm thinking if we had,
The lines on top of each other.
right, if we had the same line that we graphed, but maybe they had opposite, their inequalities were opposite of each other. One would shade the right half, and then the other would shade the left half. That's a
So
possibility.
then would that one be all in one?
Everything, now if the inequality wasn't equal to, if it was less than or greater than, then it would be everything except for where that dotted line was. But if it was, either of the lines were equal to on that case, then it would be everything on the graph could be the solution. Good questions. Any other questions? Okay, we are going to do some more practice with this. I have a handout for you. Graph paper. We're going to do some of these together, so we need a little more practice on that. Let's start with example number 1. I'm going to just have an assignment, so we want to staple that as well. Example number 1. Now, it just so happens on example number 1 that they're already in slope-intercept form for you. That's nice, isn't it? Got it ready for you. All you have to do is graph. So on that first inequality, let's graph it. What's your y-intercept? 1. +1. So let's put a dot at +1. What's the slope?
-2 over 1.
-2 over 1. So down 2 and right 1. Down 2 and right 1. Again, I would go through your graph as far as you can with your points. For this first inequality, will we use a dash or a solid line? A dash. So let's do our next step. We've graphed it. We've decided it's going to be a dashed line. Now we're ready to shade. How do we know what side to shade? Test the point. Let's put 0, 0 in for x and y. We'll go down here below. 0 is greater than, -2 times 0 is 0, and 0 plus 1 is? 1. Is that true? Is 0 bigger than 1?
No.
That's false. So looking at my graph, the side with 0, 0 is false. So which side would I shade? The other side, which in our case would be the right side. So you can take your marker and shade on the right side. So for the second inequality, let's graph that. What's your y-intercept there? 3. So put a dot at 3. What's our slope?
1.
Rise 1, run 1. So as you're putting these points on it, it's kind of important to be thinking. Will we use a dash or a solid line? Solid, and how do we know?
It's got the
Got that solid line underneath it, just like Kimberly told us. So draw our line through, our solid line. And of course our next step would be to test our point. So if we put 0, 0 in, we have 0 is less than or equal to 0 plus 3 is 3. Now ask yourself, is that true? Is 0 smaller than 3?
Yeah.
It sure is, that's true. So what does that mean about the side with 0, 0?
True.
It's true, so we'll shade this side. So when we graph these, where's your solution?
The shade, the side that shaded with the color.
Where the shadings overlap? Right in here. I'm going to use a third color just to shade in that area. On your papers, please make sure, homework, quiz, test, doesn't matter. Make sure it's very obvious where your shadings overlap. I shouldn't have to guess where you want me to think your answers are. Let me ask you guys a question. I've given you 4 ordered pairs off to the side of my graph. How would you know if these are solutions to the system of inequalities? Okay, you could plug it back in. Is there another way we can figure it out?
You could
Plot 'em on the graph.
Okay, so if we plotted them on the graph, what would we be looking for?
the ones that are solutions.
How do we know if they're solutions?
It'd be inside the shading area where
So
they
you're
overlap.
saying anything in this, if an ordered pair falls in this shaded region, then it's a solution, right?
Yeah.
And that means when I plug it back in, somebody said plug it back in to test them. So when I plug them back in, that would tell me if it's a solution or not.
Yeah.
Alright, so I want you to look at these 4 ordered pairs. I think there's just one that's a solution.
Yeah, there's only one.
Yeah.
Which one?
It's 3-1.
3, 1. And let's talk about how we know. How do we know that 3, 1 is the solution?
Because it falls into the area that both are shaded.
It's approximately right here on our graph. It's kind of hard to see color shading start. It's approximately right here on our graph, which is definitely in that shaded region. If we test that ordered pair, we could test it into our inequalities, and it would be true. It is definitely an ordered pair. On your EOC, I could see them asking a question similar to this. They're going to give you a graph. They might give you a graph and give you 4 ordered pairs and say, which of these is a solution? Would you be able to easily tell? Yeah, just look at the graph and tell, right? What if they didn't even give you a graph? What if they just gave you the system of inequalities in the 4 ordered pairs? Would you be able to pick out the one that's the solution?
Plug it in for X and Y.
Plug it into the Y.
Yeah, just plug it in, right? Put it in for X and Y. When we go through problems, I want you to start thinking, how could they ask me that on that EOC? Because it's going to happen. You're going to see problems like this. This is something that they want you to know, so they're likely going to ask you a question. Okay? Now remember on the EOC, most of it is multiple choice. There is one small part that would be a constructed response, and we'll talk about that when we get there. But a lot of multiple choice. So you've got to be able to think. There's not just one way to arrive at the answer, is there? There's always multiple ways to get to that same point. So start thinking about, how might I arrive at that answer? How would I do this if it was written as a multiple choice question? That's why I've been giving you lots of multiple choice questions on your test, in hopes that you'll start thinking that way, so we get ready for our EOC, you'll be familiar with those types of questions. Question?
Isn't the EOC taken on computers?
It sure is. Our EOC is taken on the computer. Now, even though it's math, you may still have to type in some equations or graph some lines on the computer, and there's some practice tests that we'll go through and practice that before we get to that point. But I just want you guys to be thinking, that you know what's coming. It's coming. Example number 2 is a good one to look at. Why do you think I picked out this one?
Because one line, there's no X value in one.
Yeah, that first inequality always gets people. Is this, looking at that first inequality, there's only one variable, correct?
Correct.
One variable. So we know it's either going to be a horizontal or a vertical line. How in the world do we tell which way? Because I know that's always the question, is to go this way or to go that way? Laura?
Well, you just go up 3 because it's Y, so you know Y is 3.
Uh-huh.
So you just go up the Y-axis, and it's going to be 3 all the way across.
Okay, so any ordered pair we put in is going to be something comma 3, something comma 3. Good way to think about it. Does anybody else think about it a different way? Logan, what about you?
The way I think of it is, if it's on the Y-axis, then it's a horizontal line, and if it's on the X-axis, it'd be vertical.
So if it's Y, it's going to be horizontal.
So it's
And not the upside down.
It's
Upside
the
down.
upside down
Upside
Y.
down H.
Yeah, that's
Wait.
what I mean, because I don't know.
I'm sorry.
Flip it.
The Y is an upside down
Good,
H.
you guys remember that.
Yeah.
Earlier this year, didn't I tell you if you took your Y and you flipped it upside down?
Yeah.
Yeah.
Doesn't it kind of look like an upside down
Mhm.
H? Sort of,
Yeah.
kind of?
Yeah.
Okay. So that may be another way to remember it. Laura's got her way that she's thinking if she tests the ordered pairs, the Y value is always going to be 3. Emily, did you have a different way?
I was just saying the H thing.
Okay. Kimberly, what about you?
If it has a Y, it would be going on the X-axis because it's missing the X.
So it's never going to touch that X-axis, is it? That's another good way to think about it. Kimberly says it doesn't have an X value in there, so it'll never touch the X-axis. So draw it in so that it never is going to touch that X-axis. I like your thinking, guys, because what works for me may not work for somebody else, huh? So I want you guys to start thinking and talking about, how are we remembering this? How do we graph these lines? Especially these that you guys should be able to graph easily, but they're those tricky ones that you just can never remember if it's horizontal or vertical. So anyway, back to graphing. We know it's going to be a horizontal line at 3. We've got that down, correct?
Correct.
So let's go ahead and draw our horizontal line at 3. Now, will we draw a dash or a solid line?
Solid.
In this case, it will be solid. All right, we still have to test our point. Now, somebody might say, well, there's no X value to test. That's okay, isn't it? Yeah, just put 0 in for Y. Is 0 less than or equal to 3? Yeah, that's true. So the side with 0, 0 is true. In our case, it would be the bottom half. We would shade down here in the bottom half. Now for the second inequality, it's not in slope-intercept form. What could we do to put it there?
Subtract X.
Subtract x. So we have y is greater than or equal to negative x plus 1. I'm going to do this in red, actually. So what is our y-intercept on that second inequality?
1.
Positive 1. What's our slope?
Negative 1 over 1.
Negative 1 over 1. This time will we use a dash or a solid line?
Solid.
Solid. We have a solid line under inequality, so we will use a solid line on our graph. We still need a test or point. Now let me ask you, does it matter if we plug it into the original inequality or the one that we've rearranged in slope-intercept form?
It doesn't matter.
It doesn't matter. Now let me ask you, what if we had to multiply, or what if we divided by a negative or multiplied by a negative, and we forgot to switch our inequality symbol? Did everything else right, just forgot to switch your inequality symbol. Means you're going to shade the wrong side, right? To avoid that common mistake, I would recommend trying to plug it into the original inequality. Because that one you didn't change. You guys can solve for y easily, but it's common that people forget to flip their symbol. So I'm going to recommend you plug it into the original. So if we put 0, 0 in, we have 0 is greater than or equal to 1. Is that true?
No.
That's false. So looking at my red line, my point was 0, 0, which is on the bottom side, was false. I want to shade the true side, so I'm going to shade the top half. So remember, our solution is where our shadings overlap. Could you give me an ordered pair that falls into that? I shouldn't say. Can you give me an ordered pair that's a solution for the system of inequality? 2, 1. Perfect. Can you give me another one?
3, 1.
3, 1. 2, 2. What about 50, 0?
Yes.
How do we know it's not on our graph?
Because it's on the
It's extending
X.
to the
It's just on the X
right
and it's
side.
just gonna stay.
Our graph keeps going, doesn't it? It doesn't just stop here because my graph stopped here. That just is where it happens. Stop. If I go over 50 units and up 0, I'm going to be somewhere right over here, but it should be in that shaded region if we extend it out.
Because it's still on the X-axis. 50, 0,
Good thinking. I want to look at one more with you, and that's example 3. Example 3. Now these inequalities look very similar, don't they?
Yes.
Okay. So let's keep that in mind. First inequality, what are you going to do to solve for y? Subtract 2x. So we should have y is greater than or equal to negative 2x plus 2. For the second inequality, what would you do?
Same thing.
Same thing. So what are we thinking about the slope?
If they're parallel.
If they have the same slope, they're what?
Parallel.
Parallel. Think about two lines. If they're sloping the same direction, are they ever going to touch?
No.
No.
No, they're going to run side by side. They'll never have a different slope. It's going to cause them to intersect. So we should have two parallel lines when we graph it. Use that to help you. Now, you can't just say no solution because it's not always the case. Let's go ahead and graph this and see what it looks like. For the first inequality, what's your y-intercept? 2. And the slope?
Negative 2, 1.
Negative 2 over 1. So down 2 and right 1. Could go up 2 and left 1. We'll use a dashed or solid line for the first inequality.
Solid.
Solid. Let's talk about shading. Which side of our line are we going to shade here?
We have to.
Right.
So I have tested 0, 0. Is 0 bigger than 2?
No.
No, 0 is smaller than 2. That's false. The side with 0, 0 is false. We want to shade the other side.
So I get really confused on which side to shade.
Okay, let's go back through this. Are you okay with putting the ordered pair in 0, 0?
Yeah.
Okay, so I have this inequality right here. Is this inequality true or false?
Oh.
False. So Zeke, if you think about that point right there that I just put a dot, that's for 0, 0, that's correct? When I put that in, that was
True.
false.
Yeah.
Put it in, we said it was false. So that means everything else on this side of the line is going to be false as well. Any other ordered pair on this line is false. And we want to shade the true side, so the other side would have to be the true side.
Okay, I got
That answer your question? Say, stop me again if it doesn't. We'll go back through it. For the second inequality, I'm going to do this one in red. What is our y-intercept? 4. And we have the same slope, correct? -2, so we're going to go down 2 and right 1. This time when we use a dash or solid line. Dash line. Let's test our ordered pair. Is 0 less than 4?
Yes.
Is that true?
Yeah.
Okay. So stop me if I get confusing, okay? If I put 0, 0 in, we said that was true. So I'm looking at my graph, and it might be helpful to put your finger there at 0, 0 to help you think through. Alright, so we put 0, 0 in, we said that was true. So I'm looking at the red line this time. Put 0, 0 in, it was true. So I want to decide with 0, 0 or without 0, 0. With, because it was true. So with 0, 0. Is that okay? So we're going to shade, in our case, the left side of the bottom side of this graph. Now these graphs are pretty close together, so it may be tricky to tell where your solutions are.
That's a small area.
It is. Where are your solutions?
Right between the 2 lines.
Right between. So right in there. And I kind of like to take a different color, a third color, and shade in where the solution is. It really makes it easy to tell where your solutions are. So you guys have this handout that I just gave you. I'm going to pass around this stapler. I want you to staple this into your note sheet or your notebook. I want you to have it somewhere safe that you can reference it again if you've got a question. I do have some problems for you to try. They're out of your book. I think there's 8 of them. So on page 384, 1 through